Hello and welcome everyone to my channel Code with Ease. As part of the array series, today we are going to learn about a very popular algorithm called the cadence algorithm. And the problem that we are going to solve is called maximum sum subarray, and it is also known as largest sum contiguous array. So before we understand how this algorithm works and how are we going to use this algorithm for this question, it is important to understand why do we even need this algorithm to solve the question maximum sum subarray. For doing that, let's understand the problem statement, then let's think of the brute force ways, and once we are not able to achieve a good time complexity with the brute force way, is then we are going to understand why actually we need this algorithm, the cadence algorithm. So with that, let's get started. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving and programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy-paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. Let's first take a look at the problem statement. It says that we are given an array of n integers. Find the contiguous subarray, which consists of at least one number and which has the maximum sum, and return the sum. So basically we have to return the maximum sum. We don't have to return any subarray. The first question, what even is a subarray and what does contiguous subarray means? So contiguous subarray is simply a subarray of an array, or like a subset of an array, in such a way that the elements of the subarray should be in the exact sequence as the sequence of the elements. Like for example, if you consider this array, 1, 2, 3 is a subarray, 2, 3 minus 2 is a subarray. These are all smaller sections, or these are smaller subsets of the same array only, but they are in the same sequence as they have appeared in the array. That is what is meant by the contiguous subarray. So the objective of this question is we have to find out any such subarray whose sum is the biggest, the maximum sum, and then we have to return that maximum sum. That's it. So as we can see in this example, the output is 9 because 1, 2, 3, if we sum it up, all these elements, we are going to get the sum as 9. The array itself also is a subarray. The expected time complexity is linear and space requirement is constant. So with that, let's move to the whiteboard to understand first the brute force way of solving this. Then we will move on to understand the cadence algorithm and the application of that for solving this question. So here is the sample array that I have taken, and this is the time and the space complexity required. So in this array, we have a mix of negative and positive integers, and we are supposed to find out, as we discussed, the maximum sum of the subarray. So here, as we can see, there are 5 elements and there can be multiple subarrays formed from this, but the one which I have highlighted in red is the subarray which has produced the maximum sum, that is 5. Hence, this is the required subarray and this is the required sum that we have to return. Why is it so? If we add this up, 4 plus 2, 6, 6 minus 1 is 5. So let's now discuss the brute force way of solving this. What we should usually do, we are given an array and we have to tell which subarray has the maximum sum. Keeping aside the maximum sum part for a while, first thing what we have to do is to find out the subarrays. We are given an array, we have to find out the subarrays. How do we find out subarrays? We have to use loops. So we'll use 2 loops. The outer loop, we can run it from 0 to the last element, from here till here. And we can also have another inner loop which we can run from index 1, or let's say if the outer loop is being pointed by I, we can run it from I to n. How will this help us in finding the subarrays? First, we keep our outer for loops pointer over here, and the inner for loop starts also from here. So when I is equal to 0, only the first element forms our first subarray. When I is over here, using the inner loop as I to n, we can form all the subarrays from the first position to the last by adding each element one at a time. Like first it will be minus 3 and 2, then minus 3 and 2 and minus 1, then minus 3, 2, minus 1 and 4, and so on. Again, when the I moves forward, then our subarrays, how will it be? From starting from here, it will be like from 2 and minus 1 will be one subarray, 2, minus 1 and 4 will be another subarray, and in that way, so on and so forth. Again, when I moves here, our subarrays will be minus 1 and 4 will be one subarray, minus 1, 4 and minus 2 will be a different subarray. So basically, by the combination of these two loops, we are able to generate the subarrays. Now, if we are able to generate the subarrays, we have to use some kind of a manipulation logic to find out the sum. How can we do that? Some variable we can use. So what we can do, let's say the name of the variable is sum. We will use sum equal to sum plus ARR of j, and we'll compute the sum inside of the loop. And just after computing, we'll also do this check if this sum that we have just computed, if that sum is greater than max sum. We also need a max sum variable, which we will put it outside of the loop, and accordingly we will manipulate, and into this variable we are going to solve, and into this variable we are going to store the actual maximum sum if this condition is coming out to be true. But this sum variable we are going to initialize when? At the beginning of the inner loop here. Just before the inner loop is starting, at that time we can initialize this sum variable, and then we are going to set it to 0, so that at the start of every inner loop we are going to compute new combination of subarrays. When the inner loop is starting from I to n, we will get a certain number of subarrays. If that is not done, we are resetting the value. Once we are resetting the value, then we are computing the next set of subarrays, and then we are doing the logic to check if it is greater than max sum and so on. So in that way, basically we can solve this entire question, and we can generate the maximum sum of the subarray. Fair enough. What is the problem for this? As many of you might have guessed it, what is the problem for this brute force? Two loops, which is causing order of n square complexity. So we don't want any kind of exponential time complexity whenever we are trying to optimize any algorithm, whenever we are trying to optimize any problem. So then we have to start thinking in terms of reducing the number of loops. So our goal should be reduce number of loops while keeping the space constant. In this case, we anyway have not used any additional space. So space is anyway constant, but the loops are, we have two loops, we have to reduce the number of loops. So from this goal, the usage of this cadence algorithm comes into picture. How this algorithm helps? In simple words, it helps in two things. First, to get the constant space complexity that we want. And instead of two loops, it will help in solving this question in single traversal, means in one loop. So we can get order of n complexity. And this is exactly what we want. We need order of n time complexity and space complexity to be constant. That is why we are going to use this algorithm. Now let's understand how this algorithm works. So before we understand the pseudocode for this algorithm, let's understand the central idea for this. So the central idea for this algorithm is, as we have told, this array is going to have a mix of positive integers and also negative integers, and we need a continuous and we need a correct sequence of elements which can have positive integers also and it can have negative integers also. The most favorable part is the sum will be maximum when we have more positive integers and less of negative numbers, right? We need more of positive integers. So what this algorithm tries to suggest is, okay, fine, you take in positive integers also, you take in negative integers also, and keep on adding it to some variable called sum. But there's a catch. If this variable sum's value at any given point in time turns out to be negative, like if it is lesser than 0, reset the value of the sum, reset to 0. It's just completely erase and delete and discard whatever you've collected, erase and delete, and then continue taking newer elements. Why this is being done so? Because if my sum at any given point in time becomes a negative sum, so in that case, I should not be considering that sum only. I should try to look for newer elements which can help me in getting a maximum sum. Why do I need a negative sum? I need a positive sum. So that is the central idea which I was trying to bring forward. This is what this algorithm tries to do. In the above brute force, if you remember, this part will still be reused in cadence algorithm. In the single traversal in one loop only, this sum also we have to do. We'll keep on adding every current element to the sum variable, and this check also we are going to do. This much is still common. This we anyway have to do. But in addition to that, there is an additional check which is happening, that please check if this sum variable at any given point in time turns out to be negative. And if it does, reset it. So that is what the algorithm states. So it is as simple as take a variable called sum and make it to 0. Also take a max sum variable and set it to integer dot min value. That is step number 1. Start your for loop from 0 to n minus 1. Third step, inside the for loop, make this calculation like sum equal to sum plus whatever the current element is. Do the sum and then check if this sum at any given point in time is greater than whatever max sum we have as of now on. If it is greater, then put this sum inside max sum. Till here we were anyway trying to do in the brute forces inner loop. This much was still constant. Something similar we were doing. Now the additional check is happening over here. If this sum, whatever this sum we have calculated, if this becomes less than 0, means if it is negative, then reset the value of the sum to 0 and then start the for loop again from the next element. And finally, return max sum. So whatever has remained stored in the max sum, that will remain untouched. Only thing is, to this max sum, we are going to change the value of this max sum only if we find a certain sum which is greater than the max sum. That is why we are doing this. And if that sum itself becomes negative, we are discarding it. We are just throwing it away and we are resetting the value. So that we are now in quest of other elements which can help us in giving a bigger sum or maximum sum. So that's about this algorithm. Now let's see the code implementation for this. So starting with the code changes for this, first let's initialize the max sum variable and the current sum variable as 0. So at first we have to add the current element to this. So we'll do ARR of I. Just after adding, we are doing this check whether this current sum is greater than the max sum which we have taken. If it is, then max sum will be equal to current sum. Separately, we are also checking if at any point this current sum has become negative. If that is the case, we are resetting this to 0. And finally, we will, after the loop is completed, we will return the max sum. Yeah, that's it. That's all about the code. We'll submit this. So that's about the special maximum sum subarray using this algorithm, the cadence algorithm. Hope you guys have enjoyed it. Do let us know in the comments below if you guys have any questions or doubts or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.